passive house multifamily design. I'm going to be primarily doing this through looking at a comparison from sort of a base code multifamily buildings to this particular building here itself, and focusing mostly on architectural elements. This is the Building Enclosure Council, and I'm not a mechanical engineer or an expert in all things. So I'm going to focus mostly on the elements that I am most knowledgeable myself in. First, I just want to, sort of mention the project team here. And sorry, I don't know if you guys can see this, but it seems to be in my way. And just mention that this is truly a team effort, and I'm by no means the expert in anything passive house. I see myself more as the facilitator of all of these other experts, and primarily just Beacon Communities with their partnership with the Boston Housing Authority has just done a fantastic job of facilitating this project and having it meet its pretty strong sustainability goals itself. So first, we'll talk about a little context here. So this is the site we're talking about. This is in South Boston, right near Moakley Park. Back in 2009, before any of this redevelopment had started, this was actually one of the oldest federally funded public housing complexes in the country. And since 2009, with almost the same team from that get-go, we have been redeveloping this public housing project into new affordable housing. And even from the beginning, it had very strong sustainability goals for the project. I mean, the first phase was all LEED Platinum. This was back when LEED was sort of the cutting edge, and through each phase, we've just sort of tried to push that boundary until we've gotten to where we're at now. Again, just some context photos of what you're seeing. Here's what it looked like currently before phase three, and then phase three. And so I was saying, now we get to phase three, and the cutting edge is passive house. And so we had this unique opportunity to realize this 3C building as almost a test in affordable multifamily housing and going passive house. And so the client ownership, everybody was all gung ho about it, and we just went for it. And so that's what hopefully going to be able to give you some insight on today. Just a little bit more context, a little zoomed in, you can sort of see where we're at. 3A is nearing completion. That's the two buildings up near Dorchester Street. And then 3B and 3C are both in construction now, with 3C, the smaller building here, being the passive house job. First, most of you probably know what passive house is and the ideas and concepts behind it, but if not, I'll just give you a brief introduction to really what it's all about. Essentially, it's really just a set of design principles that focuses on different strategies, both active and passive, that's about optimizing building performance and comfort, right? And so most of what we're going to talk about today is more of the passive strategies. I'm not going to focus as much on the active mechanical strategies. But the thing to know about passive house is that it is essentially one of the most effective strategies to getting toward net zero and net positive buildings and reducing carbon emissions. There's so much focus that needs to be had on reducing those carbon emissions, and there's all of these goals that the AIA has set, or the city has set. The U.S. has just rejoined the Paris Accord, and so passive house is just a very effective tool to actually meet those goals that everybody has set. And it's the smart thing to do when building. There's basically two types of certifications right now for Passive House. There's FIAS, and then there's Passive House Institute. FIAS is the US standard. Passive House Institute is the German standard. Basically, the main difference between the two is Passive House Institute has a general certification level that they apply across the globe. They have the same threshold, where FIAS uses climate-specific data, and they tailor your goals, whether it be for peak heating, peak cooling, etc., based on that specific climate itself. I think that there's some arguments to be said of the advantages of having a climate-specific approach, and we certainly went with the FIAS approach and not the passive house. Not to say that one is necessarily better or the other, but just for sake of being open, FIAS is what we've designed to, not Passive House Institute itself. The fundamentals are just similar things you see here. So building orientation, so this would come into play in terms of solar heat gain, shading, daylighting, building location for envelope performance, massing. You'll see later on that a compact massing, which sort of intensifies the internal loads, can be helpful. Increasing levels of insulation, importance of air tightness, and really reducing the amount of thermal bridges. And you'll find that in most passive house, particularly multifamily passive house, there's a renewable resource components to this as well. And then the active strategies, which a mechanical engineer for sure is more qualified to speak to, but balanced ventilation with very stringent air quality levels. You pretty much need an energy recovery system, and then super efficient and small size heating and cooling systems for the building itself. So now that's the brief introduction. We can just focus on Old Colony Phase 3C itself here and dive into the specifics about this project. So I'll give you a little bit of building information first. So the building is approximately 51,000 square feet. It's all one bedroom units. It's for senior affordable housing. There's 55. There is a pretty large, you can probably see it on the first one according here, but a pretty large component of the first floor is a community wellness center. So that takes up a decent amount of square footage. And it was permitted back under the 2015 IECC. It's in Boston, so obviously Article 37, all of that apply. And so we're LEED certifiable gold on top of FIAS, et cetera. And FIAS, one of the components of it is that they add additional checklists on top of that. So you have to be Department of Energy, zero, I don't know why I'm blanking on what the ZERH stands for, but Energy Star, Indoor Air Plus, Water Sense, et cetera, right? So there are additional certifications that the project will be getting as a result of just going for FIAS Plus. FIAS has changed. There's newer updated standards from 2015 or FIAS Core, but at the time when the project was designed, that's what we had designed for. So it's 4 stories, Type 5A construction, and from comparisons that I'll be referencing as we go through this presentation, and you'll be seeing different assemblies and R values, et cetera, are just 4 other projects that we have in our office as well. I tried to get a range of different types of housing from, Project A, which is more market rate, to high end, with Project D actually being one of the other buildings that we're constructing as part of Phase 3. Which is not designed for FIAS, but just for LEED Gold, right? So essentially, these are all wood buildings, Type 3 to Type 5. They're all LEED certifiable, LEED Gold, all in the Boston area, and they're all multifamily, which I think is key to try and give you sort of a level playing field. They're also all done within the last couple of years or in progress now, so it also tries to help give an even comparison to what we're going to be looking at. And before we get into specifics of the actual envelope and some of the actual thicknesses, R values, et cetera, just talk about some overall building design strategies that I would argue, and should be different in any multifamily project that wants to go passive house, and then in general just will impact your performance, right? So the part of passive house is that there's a ton of different ways to meet these performance goals, and there's no one right answer for every project, but there are certain strategies that you can apply from overall building design which will help and affect the actual building itself. And so the first one is this massing and orientation. A simple, more compact form is going to give you a easier envelope to insulate. It's going to hold all of your internal loads into a smaller volume, and so you have less envelope for your, basically FIAS works on a resident per square foot amount essentially, and so you're internalizing all that into a smaller compact volume. And then the orientation itself also really comes into play, because if you're trying to maximize your solar heat gain or minimize how much heat gain you're getting in certain times of the year, etc. How that building is orientated towards, the sun and south and different orientations is going to come into play. For this particular project, we didn't have a ton of options. There was streets on essentially three sides and a building on the other side, and it was right on a corner. We knew we wanted the building to respond to that more public corner. And two of the streets faced southwest and southeast, and so it was fairly simple for us to get to this pretty simple L-shaped form that was compact and had a lot of solar exposure. There isn't a lot of site shading elements in that area either. So it was a fairly simple decision for us and how to get there, but it won't always be that case. And so when you are focusing on, a new design, what strategy you take for this will have a big impact. A really complex building with a lot of appenditures on it or bays, etc., just introduces more instances where there could be thermal bridges or harder to detail, and there could be transmission loss through the envelope, etc. And so it's not to say that you have to design a boring building. I would argue that you can design an attractive building in a simple and compact mass. But it's a strategy which will help optimize the building performance itself. Secondly, it's your approach to structure. Um, Again, there's just schools of thought of how you should approach it. I think that if you're truly thinking about optimizing, which is the goal of Passive House, you want to be including your structural design strategies into this. Into this goal itself. And so we actually did this with a few different strategies. One which being the strategies for the framing, and then we actually looked at opening size as well. So just to talk briefly about the framing. A lot of people, when you think Passive House, particularly with single family residential homes that have to go Passive House, you're really focusing on minimize thermal bridges because there's so little internal loads for the amount of square footage. But on a multifamily residential, you don't have to do that much different. We could have actually not done any sort of advanced framing, increase the stud spacing at all. We could have went with 16 inches on center for the whole building, and we would have met the Passive House model. But because the team had strong goals from the get-go, we pushed to get to the 24 inches on center spacing with advanced framing. And most projects, at least in our experience, that are wood frame Passive House, wood frame multifamily, you're getting a panelized construction anyways. And so the advanced framing component's not that much more difficult to achieve. And so since you're already, drawing out, or, the subcontractor is drawing out every stud in the building and laying out all of these, and it's going through a full VDC model, it's really not that much harder to achieve the 24 inches on center spacing, throughout the building. And so with all those different considerations in mind, and not really realizing much of a cost difference for doing that, we did pursue the advanced framing, which of course just increases the amount of insulation in your wall. But the second strategy we took, which is something we knew we wanted to focus on from the beginning, was limiting the thermal bridge at opening headers, right? So wherever you have a header, you're typically going to have a pretty solid framing element over that opening. And then secondly, if you have to transfer any loads, like we have this ground floor area where there's a desire for not a lot of load bearing walls. And so we have a steel component. Is, how do you do the structure to limit any steel on the exterior wall, because the steel itself is definitely not as thermally performing as is wood, right? It's very thermally conductive. And so the two strategies we took were we worked with the structural engineer very early on to really limit the amount of steel on the exterior wall, push all this here towards the interior of the envelope. And then secondly, we worked with them to figure out what would be the largest size opening that we could have on the building while still being able to maintain an insulated header. And when we looked at it with the analysis, it was somewhere around 6'6". And so you'll find on the project, we don't have an opening anywhere that's more than 6'6" wide. And we just applied that and used that as a module. And didn't necessarily design the building around it, but use it as a parameter to design openings, and use the patterning and spacing of these different width openings up to that dimension, and to try and maintain that. Now, again, it's not something you'll find, and when we get to the presentation, we'll sort of talk about lessons learned. It's not necessary, but again, it's just another step to help optimize that performance in the building itself. Secondly is the approach to your fenestration. So part of it's the size, which I talked about it, but not only is it just the size of each particular opening because of the structure around it, but it's going to be your window to wall ratio, and then a shading or not shading component of it as well. The ideal for passive house is going to have more wall insulation than than it is openings. A window, even at a passive house window, when you have really high U values, is still not going to have the same performance as a solid wall. And so, again, the strategy we took from the beginning was, what's that minimum window to wall ratio that we want to be at to optimize the performance. We were right around the 20 to 30%. I think you'll find that most passive house projects will probably be at that 20 to 30% of window to wall ratio. It's not to say you can't do a passive house project that has much more windows, but you're going to have a much harder time meeting all of those performance goals, and you'll have to increase other aspects of your design, which of course all impact cost. And particularly in affordable housing, cost is a very important deciding factor. And so we had to kind of keep all of that in mind. But as I was describing, the other component of that is that, there, although New England is primarily a heating dominated climate, it does have a very strong cooling component. We have very hot summers, and this building, like I described, has essentially no site shading on it, and two of the main elevations face southwest and southeast, and so we were getting a ton of solar heat gain, and because for a variety of reasons, of primarily this one bedroom component, which I'll touch on the end, we determined that we actually needed shading in order to meet our cooling load. And so we had to design it into the project and find a way to one, make it work architecturally where it doesn't feel applied and sort of an afterthought. But then also, the other component of it is that because passive house is about this optimization, and we had the advantage of having a team working on it from the beginning, we're able to use the energy model and actually determine exactly what's that sort of break even point for us, and what the depth of that overhang for the shading needs to be, before we pass or fail, etc. And it was right about this 18-inch dimension minimum. If we went any more than that, the cost was going to be too great, and anything less than a foot, we were going to fail. And so again, the design is really looking at performance as a design factor, and then using that as a parameter to design around. And then lastly, the one thing you will probably find that is going to be much different about a passive house project over a traditional multifamily is that while Article 37 and other goals may have you design for a future PV array on the building, you may not always be installing one. You will probably find that most multifamily designs will include a PV array. It's a cost-effective strategy to get to some of the performance requirements that passive house and particularly FIAS has. And so you can offset your energy production that you get from your PV array on your total energy production. And so what you'll find is that when you are doing all of this analysis in Morphe Passive, which is the energy modeling program used for FIAS, is that it's actually maybe cheaper to add this PV array to get below this performance requirement than it would be to add an additional 2 inches of continuous insulation around the whole building to get to this performance requirement, right? And so the PV array can be thought of as this tool for meeting passive house especially when you analyze the cost of that, and buyback, etc., versus the cost of other upfront cost on the envelope itself. So as you can see here, this is just, we have about a 35 kW system on the building itself. The important thing to note is that, if from the beginning you're going to know you want to use this solar array as a strategy, or in some ways the way we thought about it is it's also a buffer. So if you get to the end of the project and you might be close to some of these thresholds, the PV array gives you that sort of extra buffer to make sure that you will still pass. But it has to be thought about from the beginning, because it requires really coordinating where you're going to place all of your equipment on the roof of the building, and it requires some forethought. And so this was just another component of this building design that it may be slightly different from a past house project that takes more importance here than maybe a traditional multifamily would. So that's the quick summary of just the overall building design elements that will most likely be different for you if you were to attempt to do a passive house multifamily project. But now we can get into more of the specifics of the envelope components itself. And the goal here is to describe how very similar your envelope can be on a multifamily job, to a passive house one versus a typical one. And we'll do this for each of the components. But the first thing that I want to touch on is, when everyone thinks of passive house, it's all about increased level of insulation and tons of continuous insulation, etc. And so obviously there's many ways that you can meet that. But we'll get into some of the strategies we specifically chose here. Again, back to our project comparisons. This is what we're going to be basing all of the comparisons on here from those 4 projects. Here's what those wall assemblies look like. Most multifamily jobs, at least what we do, they're all going to have continuous insulation at this point. It's pretty atypical to do a job without continuous insulation. Now, it's not a ton, but they will have small components of anywhere from an inch to inch and a half. In one case, you can see there's a 2-inch as well. Most slab insulation is around the R10 value, and then roof insulation is around an R40. So that's about 6 to 7 inches of polyiso on the roof. And these are all just standard 2x6 walls. Fill the insulation 16 inches on the center, right? So this is what our comparison is going to be. This is what I would say a typical multifamily housing project is working with right now, and we'll compare that to what we wound up with on 3C. But the component that I need to mention here is that it's one thing to just achieve passive house, but if you achieve it with materials and strategies that are worse for the environment, is it really a benefit, right? So what I'm talking about here particularly is the use of foam in insulating materials. So certain foams, especially HFC, blown sprayed cellulose, or spray foam like a closed cell, and then XPS insulation. These have extremely high global warming factors to them, and so you potentially, especially if you're using more material on a passive house job, you're creating more harm for the environment to do more foam insulation than you would be if you were to just build a code minimum building and not use foam and use mineral wool or cellulose, etc. And so our client was actually very aware of this, and they have very strong feelings about sustainability. And so we were directed, not to use foam, essentially. Only use it where you had to use it. And if you were going to use foam, make sure you use the right foam, right? Make sure you're using EPS and not XPS, because EPS has a much lower global warming potential. Or using an HFO blown closed cell than HFC. The disadvantage of this is that oftentimes those foams have the highest R value per inch, right? So you were actually increasing the thickness and the amount of material to use, say, mineral wool or cellulose, etc., to get to the R values we need to than if we could have done it with foam. So that's all to say that when you see where we wound up, you could have done it with thinner insulation. You could have done it with different products and probably gotten it a lot closer to what a typical project would be. But there would have been other factors from a sustainable design perspective that would have had to be considered. And a lot of it is this global warming potential of foam itself. So this is where we wound up with at 3C. For the slab itself, when we ran everything through the model, all we needed was R16 on the slab on grade insulation. We wound up going to 4 inches of EPS, which was approximately R19. That's just based on the actual product that was submitted and used. But so we were a little bit higher than what our minimum needed to be, but again, not drastically different than what we were seeing in our other multifamily jobs, right? Where we're at the R10 to R16 range as it was. We had one that was at R20, right? And so we're fairly close to that, a little bit higher. And then, we'll look at the wall assembly here. From the wall assembly, this was to us the most surprising. It really was not much different than what we had expected. We only have 2 inches of exterior insulation. We used a mineral board, and the wall insulation itself stayed the same. This is an R29 total wall assembly here, not again drastically much more than you would find in a typical multifamily job in our experience. And the advantage was that by just increasing the exterior insulation just enough, we were able to get that roughly 30% wall insulation R value outbound of our AVB, which allowed us to eliminate the interior vapor barrier on the inside of the stud. So we didn't need this, polyethylene sheet, or we were using a serpentine membrane, but we didn't need that. And so there was a cost savings from removing that from the inside of the wall assembly, which helped offset the increased insulation on the exterior of the wall assembly. Now, there are some components of this that also would affect the sort of the premium, right? We made sure we're using a fiberglass or a thermally broken Z-clip for this insulation material, right? We weren't using what might have been a cheaper metal clip you could have used on a sort of typical code building. But again, the cost analysis wasn't that much greater for it. And so in the end, we wound up with a wall that was not that much different than our typical multifamily projects, which I think some people may be a bit surprised, as I certainly was when we started this whole thing. And then lastly, for the roof insulation, we didn't have to make any change. We were typically designing roofs for these multifamily houses projects at about an R40, and that was enough for our model here, right? And again, if we had accounted for a smaller PV array, or we had decided we didn't want this PV array, these insulation values would have had to increase to offset that. But from a cost analysis standpoint, by doing the PV and just having the insulation that we we chose to go with here, it was advantageous for us, and really not that much different than what any of us were expecting, which helped from a cost standpoint, because again, in affordable housing, when that bottom line is so important, any increase in thickness or material is going to add a lot of cost. And then we can take a look at the air vapor barrier for each of these projects, and how that product and the selection there really changed. So here's our 4 projects again. 2 are fluid applied, 1 self-adhered. At 3C, 3B, the other building, we have a mechanically fastened sheet WRB, which is definitely, I would say, on the cheaper end of all of these products we're looking at that were being used. And so it's definitely not out of the realm to have spec'd a self-adhere, a fluid applied on a typical multifamily job. On the affordable, it was a little more expensive than the client was typically doing on these jobs. But when you look at Passive House, one of the main components of it is really just how airtight that building is going to have to be. One of the main tests that they do at the end to see whether or not you pass and get the certification is a whole building infiltration test. And you have to be 0.05 CFM at 50 pascals per square foot or less, which is very, very tight. It's about 8 to 10 times tighter than you're probably typically used to doing on a building. And so the air barrier is extremely important. It's extremely important of how you detail it and define it, which we'll get into in a little bit, but then also just the product you choose and the quality of install itself. For our project, we initially had designed this to be a fluid applied. It had initially priced out as cheaper, but as we had investigated the project and kept working and working with the GC, it actually became pretty clear to us that self-adhered was the better option. There's a lot of quality control concerns with installing a fluid applied, making sure you actually get the correct thickness, et cetera, in every single area, versus a self-adhered, you're going to get that correct thickness, and it's fairly easy to install. And the other component of it was, since we were already panelizing the construction from the get-go, they were able to work with the panel manufacturer, train them in how to install this air vapor barrier, and actually have the air vapor barrier installed in a controlled environment in the factory. So we were having wall panels that were up to 30 feet long, with a pre-installed air vapor barrier on it, in a controlled environment, which resulted in a very high quality installation. And then once it arrived on site, there was a lot of care taken in how we installed these things. But in the end, our hope is that this ensures that we have a very good air barrier for the project that's installed well, and will perform and meet that performance requirement there. So this component of it, while the product itself may not be much different than what you would typically find in a traditional multifamily project, I think the approach to it and the attention that it gets will be much different. You will spend a lot more time really focusing on all of these details. Now, granted, you normally would anyway, so your building doesn't leak, but now there's an air infiltration and performance requirement that's associated with this as well. Just more photos of what that looks like, on the site. And then lastly, from a difference standpoint between a traditional and then a passive house is going to be your openings, and this is where you're going to find the most difference, as well as the most in terms of cost premium. We'll look at what we had for most of these were using double pane glass, and most of this we'll get into the detail in a second here, but they're using a double pane glass. In some of the projects we use a decent amount of double hung windows, etc. And a lot of that's just not going to be feasible for a passive house project. You have to have U values of approximately 0.17 or lower in this area, so it's a pretty low U value, and a very airtight window. So mainly triple pane, casement awning windows will be what you're looking at. And we've had other projects which use that, but the focus on a passive house job, particularly with this, really eliminating thermal bridge component, is how do we install these windows and the detail for the window installation itself. On a traditional or typical multifamily project, the industry standard when there's continuous installation would be to install a window buck around the window, and you install your window to that, particularly if you have a flange window. What this does is oftentimes is push your window to the exterior of your wall assembly, and the window buck itself is a fairly large thermal bridge around the perimeter of the window. So now we've explored different strategies for how to resolve that, right? So you can see Project C, we've introduced a piece of insulation behind that buck to help mitigate that risk, and that thermal bridge around it. On Project B, which is a strategy we've sort of applied at the other three phase 3 buildings, is because we only had 1 inch of insulation and we worked with the window manufacturer, it turned out we only needed the buck on the sill of the window, and so you could actually just fasten straight through the insulation into the framing on the jambs and head, which we only had a thermal bridge on the sill. But either way, what you wind up with is, for the most part, your window is not centered on your wall's R value. And what's important about that is that when you're condensing all of these do I know the technical term for them? No, but all of the temperature lines when you're looking at say a third model of that wall assembly is that when you've condensed a bunch of them and your window is on the exterior of your wall assembly, you're at risk for condensation. And in a passive house job, which is so airtight, you want to really limit the risk of condensation. So your window really wants to sit in the middle of that R value. But the challenge is, how do you detail that? And so um, there's a couple ways that it could be detailed. And so oftentimes, you could use a thermal insulated buck, or you could have some sort of metal clip, and so then you're to catch a return material, etc. But all of those had cost to them, and the any window that we tried to explore that had to meet all these other performance requirements of air tightness, high view values, compression, weather seal, etc. um, the ones that the project could afford didn't offer jam or head extensions or sill extensions, and so we had to figure out a solution that was applied like a trim. And so we came up with this detail of actually using a plywood buck or fin that was installed, and we just enlarged the rough opening, and so that allowed us to have a fastening point for the return material, whether it be at the jam or the head, but really limited that thermal buck itself. And so, now we're only talking about a 1/2 inch thick thermal break around the window versus, a 2.5 inch or whatever you would use for a normal window buck. And so, although it's not ideal, and it's still a thermal bridge, it was enough to pass, and it was the most cost-effective solution for us. Um, and so that's the difference. Mainly what you'll find is how you detail these openings on a passive house job will be much different than how you would do on a typical multifamily job. You're going to pay much more attention to where that window sits. How do you fasten the materials if it is sitting in the middle of the wall to return back to it? How are you limiting these thermal bridges, or in the case of what you see in the left here, of how are you attempting to provide continuous insulation, underneath an opening, etc., to limit all these thermal bridges. And so while the while the opening itself would be more expensive, and be a premium and be much different, the detailing of itself will also be different. And so this was one of the uh, more areas of focus than on a typical project. Is just some examples of what that looked like. On the right is the mock-up panel. We're not at the point of installing finishes yet on the building, but on the left you can see on the building itself how that worked, and just sort of how thin that fin actually appears, and how much insulation we really be able to get tight to the window there, which was the goal. And then lastly is this thermal bridging component of passive house envelopes. It's pretty hard to just give comparisons from each of those different projects, because obviously the design is completely different. Some of them had podiums, some of them did not. So I don't have examples from each particular one. But I mean, the basic strategy is the same, as you're just trying to eliminate thermal bridges wherever possible. It's not that you can't have them. I mean, there will be thermal bridges on the project, but you're doing your best to really reduce them. And if the project had unlimited funds, then it would be great. You could go with all of these innovative strategies of using different insulation types and whatnot. But with most of the time in multifamily, you're looking at cost-effective solutions. And so we were able to find strategies that just wrapped the continuous insulation as much as we could. It had to change some of our approaches to how we applied finished materials themselves, or how we thought about using a finished material in certain applications, whether it be a soffit or add canopies, etc., like you're seeing here. But what we wound up with was that the envelope install is fairly consistent in all of these different conditions. It's really just maybe changing how you think about installing the components themselves, to really make sure you're not getting as many thermal bridges as possible. And as you can see, even here, like, at the end of the canopies, there's some instances where it's almost unavoidable without a lot of added cost. And so as long as you have all of these components modeled and you've looked at the energy model itself, you can still pass with them, but you really need to limit them as much as possible. So that's sort of the last focus on just the envelope and building design itself. And then the last component of this presentation I just want to touch on is the difference of how you actually implement this in a passive house job and what's the differences there. Because as you can see, most of the actual envelope is really not that much different. You can do a passive house multifamily job with a very similar envelope as you were doing anyways on a typical multifamily job. The building design doesn't necessarily have to be that much different. You certainly can to focus and optimize on that performance, but again, it doesn't have to be that much different. But a lot of what will be different and what will dictate whether or not the project is successful I mean, for us, we're not done yet, but it feels like we're going to be successful on it. Is really how you go about implementing this in your practice of. So first was FIAS is going to require you to present what's called control layer drawings, and so you have to give them uh, details in wall sections and plans which have colored lines indicating where the air barrier is and where your insulation is and whatnot. And so since we knew we had to do this anyways, this gave us an opportunity to sort of reevaluate how we actually draw a project. And um, this was in our office the first time we actually changed the entire drawing standard of our office for this particular project to use the control layer drawing method for all of our drawings on this particular job. So, sort of gone are the days where you're printing full size sets for GCs. They all have iPads and everybody's walking around with that. And so the need for a black and white drawing wasn't really as important anymore. And so it's not that big a deal to have a color drawing. And we just found that by having color and by using different line types and colors to represent certain things, so say a dashed line is a vapor open material, or a solid line is vapor closed, etc. You could present drawings that clearly identify the the intent of the detail. And so not only is all of these uh, components important, but really it's how they get built in the field that really is going to be the determining factor of success. And so the drawings have to be very clear to the GC so that you are achieving the performance that you've spent all this extra time making sure the building will actually get through energy modeling. And so that's just what we did. And I can tell you that at least with this particular GC has really enjoyed this drawing method. They found that it's much more clear, and the subcontractors, when we're looking at site, it's easy to just look at the detail and say, look, here's your air barrier, this is what you're going to make sure is air sealed. You can see the insulation has to be continuous here. And you're standing in the field and you're like, well, it's not continuous, so like obviously we got to figure out another solution. And lastly is, so we've been doing this on some other projects, but we just have more of them on this drawing set, was really focusing on an air barrier and compartmentalization drawing within the set itself, which just highlight and clearly indicate, where these different layers need to be so that anybody on site can just look at it and understand the goals and the intents. Because oftentimes what you'll find is that communicating that down through every individual on site is where you're going to find a lot of the mishaps. It's not necessarily intentional. It's just that they may not have understood a particular requirement. And so if you just rethink your graphics as more of a tool, I think you're setting yourself up for a better chance at success. And then secondly, I mean, I can't stress enough about the importance of an integrated team and having these clear goals from the get-go on being able to achieve a successful passive house job. We were fortunate that the team has been together through all the other phases for the most part, and the GC was involved very early on. And so, from the beginning, everybody knew what we had to hit. They knew why a certain insulation or R value was important, and we weren't going to get substitutions on that or pushback, because they knew that was the performance requirement we had to hit. um, and and so the other important aspect of that is just that when you have the entire team there from the beginning, it allows you to make these really early important decisions that you'll run into on a passive house job. Particularly, what's your fuel source going to be? Are you going to be all electric, or are you going to have some components that maybe are natural gas? And you can't necessarily wait long to make these decisions because they have huge impacts on the building design. So again, there could be a whole nother presentation on just the MEP system side of this, but most multifamily jobs are going to focus on a more all electric approach than using any kind of resource like gas or sorry, blanking. But the main point is that if you don't have those decisions made early, you're going to really have negative impacts on costs and changing and redesigning later on. And so if you get the team together at the beginning, everyone gives their input, you'll have a much better chance of reaching success. And then, lastly, the performance, when it's understood, actually sort of becomes a stipulation of the contract. Meeting that performance requirement is written into the contract. The GC was, they were on board with this, but they were required to have certain quantity of their field staff trained as certified passive house builders. And the means and method are always the responsibility of the GC, but they're obligated to meet these performance requirements and get to that end goal. And so the importance of team is kind of can't be understated. Then lastly, the construction admin component of your job will be slightly different as well. And most of that is just that there will be this increased focus on the install of all of these envelope components that play into the optimization. The saying for passive house is test early, test often. The strategy we use is we actually use the mock-up panel, which we're required to build for the city, as a way to test all of the envelope details from the start till the end. And so, we did things like install an under slab vapor barrier on a mock-up panel, which you probably normally wouldn't do. And, we talked about how we would lap that around a stem wall where we needed it, or, how that would actually get tied into the wall assembly. We've sort of changed how we do our weekly meetings, where the first half hour is with a smaller team that just focuses on, potentially what's being worked on that week, to make sure that there's no questions on details, or there's, no questions about how to do something, etc. And so these are just some examples of how we looked at each of these stages on the mock-up panel, and how, we studied the install and made sure we were very comfortable with how all of these things work, so that by the time we got to the actual building itself, we could just fly, right? There was no questions. We've already tried all of these details, and we built in things like louvers and hose bibs on a mock-up panel that you wouldn't normally do, just so you knew that you'd be able to air seal that comfortably, and there wouldn't be any problems with trying to do that on the envelope itself. So that's most of what is different, and I think the key here is that it's really not that much different. You may change your approach, and you may change how you focus on things, but generally, it's not a hard goal to achieve passive house, and yet it's an extremely effective tool at really curbing emissions and getting towards net zero or net positive. And so the benefits of doing it far outweigh any of the negatives. So here's just some images of where we're currently at. Again, we're not done yet. The mock-up panel is done, obviously, but the building itself is still ongoing. We have all the openings in, and there's no way to know, unfortunately, at this current point, if we're going to meet all those performance requirements, but we feel pretty confident. Everything has been going very smoothly. And then, just lastly, just touching on, so, what do we learn? Where do we go from here? And the interesting thing for us is that we're actually in the process of designing the last phase, which is 3 buildings, and those all have goals of going passive house. And we've learned a lot from this building, and one being the premium is really not that high, right? I mean, we're at approximately a 3% premium in cost to go passive house over a typical, which in the grand scheme is not drastic. I mean, there could be arguments that it may be lower, right? The building's not quite an equal to the other ones because it it has this sort of large amenity program to it that the other buildings don't have, which are more just residential. But we also learned that this building actually was set up to be much harder to meet passive house than we initially thought, because we all have only 1 bedrooms in the project. We have a very low resident count per square foot, right? If you think about a 1 bedroom unit being about, because you only count 1 for that unit. For passive house, you're only getting 1 for every 600 square feet, but a 2 bedroom is maybe 800 square feet. You're getting 2 people, right? So if you increase your unit size, you actually are able to achieve those performance requirements much easier. And so when we looked at initial feasibility studies of designing the next phases, where we have anything from 1 to 4 bedroom units, we're finding that it's much easier to achieve, and we don't necessarily have to look at things like advanced framing or maybe limiting opening sizes, or et cetera, right? So perhaps we went a little overboard at the beginning to really optimize this building, but it may not have been necessary to actually get us to that passive house requirement. I think they're all good ideas, and I would urge you to do the same thing to really push for that performance, but it may not be necessary. And a couple of things is that who you have as your GC is going to be really important. You need them to be on the same team as you. It's one thing to design something in an energy model and make it this great piece, but if they can't understand that vision and they can't implement it in the field, then it's pretty much all for naught. And then lastly, there's a pre-certification process with FIAS that you present them initial energy models, you present them the drawings, they review it, and will tell you if you're going to get pre-certified or not. And you have to achieve pre-certification. And those drawing reviews, one, they took about the length of time we expected, but there were some changes that were made in terms of assumptions we thought we could do for excluding certain spaces or not, that had a big impact on sort of the buffers we had built into meeting those performance requirements. And so, the lesson learned there is that getting that stuff in as soon as possible and really focusing on getting that pre-certification and having an understanding from the certifying agency, whether it be FIAS or PHI, ASAP, really helps make sure that you don't run into cost related changes or changes that may impact whether or not you actually pass or fail the certification later on. But that's pretty much wraps up the presentation here. Again, there's a lot more that could be said about the systems and the difference that will go into that portion of it. But from an architectural standpoint, it's really not that much different to design a passive house multifamily job than it would be a typical multifamily job. So we can do Q&A now. I think I still have some time here. An hour done, so let me get to the chat. Assume there's some here. Here, I'll go back to, I guess there's no way I can do that with the chat. Sorry, I'm not the best at Zoom here. So I'm going to stop my screen share for a second. And all right, so first question. Let's see.
I see one from Greta. how do you achieve compartmentalization within the building?
Yep. So Passive House doesn't have any specific compartmentalization for the units, but there's other factors that do. So, energy code or lead would have compartmentalization. So our strategy, when our goal is 3HCH50, and there we're actually using the drywall of the rated walls as our air barrier itself. And so we are taking the drywall from deck to deck everywhere. All outlets are in those demising or corridor walls are getting putty packs and sealed. We're sealing drywall to the deck, and the gypcrete goes on top, seals the top, etc. So that's the compartmentalization strategy. It's a much easier threshold than the 0.05 CFM. But yeah, that was our strategy for the particular units. Sorry. What fiberglass fasteners do you use for the exterior insulation, and what bay barrier? So we used a Smart CI. That was the fiberglass tracks there, the green ones you saw. And then the Suprema is the manufacturer for the peel and stick on the exterior. So it is the Stick VP. It's their vapor over vapor permeable option, and then they have associated flashings. The Stick 1100T is what you see, the white stuff. That was their self-adhered membrane flashing that was associated with that. Let's see. Then there's a question about does Passive House specifically put restrictions on materials with high embedded carbon levels, or was that just a project? That was just a project team driven initiative. There's no Passive House requirement for what materials you can use. At least at the time, there wasn't. I'm not sure if maybe the new version does have different restrictions on the materials, but at the time there wasn't. So this was just something that, like I said, the owner has very strong sustainable goals, and obviously the team does as well. And so we just made the decision early on to really limit the use of foam there. Next question, how do the solar shades, sunshade attach? Do they cause any thermal bridging issues? So there's a product out there called Armatherm. They make these thermally broken pads. And so what we did was we used the Armatherm pads at each of the bracket locations. And so, obviously that attachment and all that detail was a little bit of a collaborative process, but there's blocking in the wall, insulation is continuous behind the blocking. The Armatherm pad is outbound of the ABB, and so the insulation is somewhat continuous. It's thermally broken at each of those locations, and so we had to that was a fun design process of how do you install the brackets and design the shades in a way so that you could side around them and not have them all go up as one piece and still be thermally broken, etc. Let's see. Did you have any difficulty getting the air barrier membrane to stay adhered? Do you have any longevity studies of its durability? So far, we haven't had any issues. I guess I am curious. The goal is that it won't be exposed to UV very long. And we'll get siding on there fairly shortly. Again, because of the panelized construction, things are moving pretty quick, so it's able to go up pretty quickly. Everything was very well pre-planned in terms of submittals and ordering of materials. So as soon as that wall was in, and it was safe to occupy that floor, windows were getting installed, right? And so far it hasn't been. I'm not sure, and I know the manufacturer has requirements and dictates sort of how long it can be exposed and maybe have some adhering problems, but haven't had any large issues yet as far as I know. Our envelope consultant has been really great at going out and really studying the install. We have sort of have him punch listing the whole building as we go to make sure that we don't have any issues with not meeting that air tightness requirement. And like I said, I'm not the expert. We certainly relied on them for a lot of it, and so far so good. Let's see, next question. What comprised the greatest percent of the 3% overall premium? So first I'll just answer that. Most of that is going to be the openings themselves, and then the mechanical systems slightly, not necessarily the heating and cooling, but there are increased ventilation levels from Passive House, and so we did have to pay a little bit more on the mechanical side, but most of it would be the envelope, primarily being windows, and then obviously there was some increased insulation at the slab and the wall, and so there was some costs associated there as well. Who are good FIAS-GCs that you recommend for multifamily developments Greater Boston? Oh, that's a tough question. Mainly because this is my first Passive House job, and we're working with Demio now, and they've done a great job. That's not to say that other GCs wouldn't do a great job. So if I guess the only comment would be is if you find that you have a GC or know of a GC that's willing to work with you during the pre-construction, is open to thinking about things in maybe a different way than they're normally doing it, they could be a pretty good option for a Passive House job. What window manufacturers do you use? We use Intis. That was the where we wound up with on this job. And then did you use in-house modeling, or was it the MEP consultant? Same question for Woofy modeling. Did in-house modeling. So I'm not sure what the question is in terms of like modeling for the MEP systems themselves. We have a Peterson Engineering did all of the MEP design themselves, and then for the Woofy modeling, although I am a CPHC, I'm not the actual CPHC on this job. It's New Ecology, and so they did all of that modeling in Woofy, and all of that analysis there. So they take our Revit model, they rebuild it in Woofy, input all the information, and similarly with our consultants, they worked with us as a team and did all of that modeling itself. Let's see. In terms of adherence, membrane prefabbing probably helped. Yep. Yeah, like I said, I haven't seen many issues on it. I mean, there's obviously a couple areas you just the fix has been to roll it back on. I guess we'll see. Time will tell if we have any more issues moving forward here. But so far, so good on the AVB. I think that's it. I don't know if I missed any other questions. If anyone has questions, feel free to ask them or put them in the chat here.
Well, I'd like to say thanks, Nate, for the great presentation. Very informative and cool project, I have to say, for Boston. And I think we're looking to, hopefully coordinate maybe a tour of the project, maybe, if things get back to being
Yeah. I mean, that would be right.
As you just move along. Yeah. Cool. Well, thanks. Any more questions?
How much did you increase? So I don't know the exact answer to that. I don't know what the percentage was. I'm not necessarily the one in our office setting all of the fees. That's for my my higher ups. I don't think it was that drastic. Again, part of that mainly because we had never done one before, so we didn't really know what it was going to entail, and it really wasn't that much more work on our end. You think about things differently and you approach it differently, but if you make that decision from the beginning that you're going to do it that way, it's not like you're going halfway through and starting from scratch. But also we've worked with this client for years and years, right? So it's just been a really good long-standing relationship with them. I'm not sure what if anything there was in terms of fees. And then there was one other question here. How does FIAS consider PV versus insulation in the long terms? PV breaks down after 5 years. That's a great question. I'm not sure FIAS necessarily would be dictating that. I'm sure that there's arguments that the team would have to review on whether or not what they think makes more sense from a sustainable design, but I don't think FIAS would have much of a opinion on that. Yeah. So again, hopefully, like Heather said, hopefully things start to continue to get back to normal, and we can do a tour and take a look at it, etc., and on the fields, and I'm just hoping things continue to go smooth and that we get our, we meet the certification and everything that it was designed for. So,
Nate, can I ask a question?
yep.
Given how tight the passive house buildings have to be, the issue of air quality, I think you obliquely touched on it. How did you approach that in this project?
Well, so that's actually part of FIAS's requirements. So they know that because the building is going to be so airtight, you have to achieve very high levels of indoor air quality. And so the ventilation requirements are very strict. You're not really, you can't get certification with anything lower than a MERV 13 filter, so you're using very high MERV levels on your filters. You're increasing the amount of ventilation. There's specific requirements, which are sort of above base code on where you have ventilation. Like you have to have a exhaust ventilation within 6 feet of ranges, etc. So there's some, additional ventilation requirements for sure to ensure, because of how airtight they are, that you don't have any issues with indoor air quality. And one of those components, and one of the checks they give you, is that you have to meet Indoor Air Plus certification for the project. So it's one of their kind of alternate strategies to make sure you also are focusing on that, as you have to follow that checklist that Indoor Air Plus gives you. One more question here. Did client consider renovation addition rather than new construction? This will likely would have much lower embodied carbon. I'm sure this was studied, back in 2009 or whenever the project started. These buildings are in very rough shape. With this particular client, we have all types of different projects with them. Some where we are taking very similar housing complexes and we're able to deem that they can be reused, and we are. So that, there's one that we have over in the South End, which is like 207 units, where we did just that. We were able to determine that the buildings were sufficient and didn't have any long-term issues, and so we reused them. But at this particular project, it wasn't either wasn't feasible, or there was some reason why we couldn't do it. It's certainly not that just their goal is just let's always tear them down. They definitely try and make the smartest decision from a sustainable approach. But it didn't make sense here. These buildings were in pretty rough shape. You mentioned that some of the subcontractors on project had passive house builder training. Did contractor require this? Any comment on this practice? So actually, if I mentioned that, I maybe meant to say the contractor. I know the contractor was required to get training, and then once we started the project, the CPHC actually gave several presentations to all the subcontractors, giving them some just preliminary training and showing them, here's what our goals are, this is what we're looking at. I don't know if any of them were required from the GC to do any official training or get any official certifications, etc. We certainly did the best we could early on through these pre-construction meetings for each phase, right? So if we were going into, we knew we were going to do the slab on grade, we get all the subcontractors that were going to be involved in that, whether it be the concrete sub, MEP subs, and just say like, look, here's what we got to focus on for this particular section. And the GC would make sure it was clear who was responsible for what, in terms of whether it be air sealing or ensuring that the insulation was continuous, or gaps were minimal, and that underside wave barrier was taped and tight and whatnot. Well, if there's more questions, keep them coming. But otherwise, thank you all for listening. Hopefully it was helpful and useful to you. Like I said, it's really not that much different. So most of you may not have been that amazed by it. It wasn't anything drastic. It's generally pretty similar to what you'd be doing on a typical multifamily job in our experience.
Great. Thanks again, Nate, for the great presentation. Very informative. I'm just going to quickly mention before everyone takes off, just an upcoming event that the BAC and BSA are going to be hosting, the WAGD Symposium on September 23rd. And there's a call for abstracts on the website now. The abstracts are due April 16th. So please check that out if you're interested. Just want to get the word out. And yeah, thanks.
Yep.
Thanks, Nate.
No problem. Thank you all.
Bye. Thank you.
Thanks.
Bye. Thank you very much. Appreciate it.
Yeah, me too. Thank you.
Yeah, very, very thoughtful and complete look at a building. Amazing.
I'm impressed with your knowledge, your breadth of knowledge, both down to the nitty-gritty details, which I always do, and the design parts. So you're an asset to whatever company gets you.
Like I said, I'm not the expert. I just
Go
do
for a
my best to
raise.
facilitate everybody.
Yeah,
It's
maybe.
nice to see the colored drawings are
Yes.
coming, because you're right. I mean, with the technology, it's totally helpful. Yeah. In the field and everything. So
Yeah,
It
I mean, we just realized that, like, I mean, yeah, sure, you have to have a printed set in the trailer, but literally every person has an iPad. Like, the subcontractor has an iPad, the GC has an iPad, you know, you have an iPad, and you're all standing there, and it's like, the screen shows color. There's no reason why you can't use that, and if it helps and it's more clear, might as well use it. So,
You know,
You must have attended summer camp. You don't know what I mean. Send me an email. I'll tell you.
but I'm just thinking that a presentation on conveying the control layers might make a really good abstract to submit for the symposium, if you're interested.
yeah, I mean, maybe I'm not the one in our offices do that. There was an individual, Mike Campbell. He spent a lot of time at the beginning going through and coming up with, you know, what colors to use to make sure that they look different than the other color and the different line types. I mean, he did a fantastic job, but you're right. It would definitely be, I think, helpful for people to see just the benefits of it. I mean, there's other benefits too, just from an architectural standpoint, how you put a drawing set together. If you're keynoting everything, or if you're like with Revit and you're not like typing out notes, if you want to change from a fluid applied to a peel and stick, you're only changing that note on one sheet and it just applies everywhere, which is just, you know, way easier than if you were to draw 100 details and say fluid applied on every detail and then have to change that to a peel and stick. You know, when you're keynoting everything and applying it to control layers, kind of helps that documentation side of it. So I like that aspect of it as well.
But it sounded like the contractors like working with it, which is an interesting dialogue to me. That, you know, drawings and specs are really supposed to communicate. You know, they're not ends in themselves. That communicates what we need better than it's great.
Right.
What about submitting this presentation for the symposium?
I don't I don't know much about the symposium, but I can look into it for sure.
Do check it out.